It is now recording. All right. First one. We are going to calculate what is 23.07 plus 9.9 and then subtract 2.86. Now, I've given you a bit of a template so you can work with it. Now, we know when we're adding decimals, one of the first key skills is to make sure that you have the place values in the correct column. Okay? Now, let's out of curiosity, what is the 7 in terms of place value? What is this one called again? Can I please have, let's go with Aegis. What's this called? Tenths. Very good. Oh, not tenths. Hundreds. Hundredths. Okay, so this is hundredths. Moving on to the next column, which is closer to the decimal point. Fraser? Tenths. Very good. These are your tenths. Moving on to after the decimal point, the next column must then be watts. Yes?
Units.
Units. Very good. Sometimes called ones as well. So ones or units. And then finally, the next column would then have to be what? Yes, Sam? Tens. Very good. Now, one of the key differences between this tens and this tenths with the THS, some students may not realize. So this is 1 unit. So it's 1. 10 of these ones make 110. So when you go that way, 10 of these tens make 1 100, and then 10 of these hundreds make 1 1000. But if you go the other way now, tenths. What is tenths as a value? What's the value?
First digit behind the decimal point.
That's true, which is technically 0.1, right? The 0.1 as a fraction. What was that again? 1 over 10. That's the one I'm trying to get to. So 1 over 10. Now this makes sense because we've learned how to multiply fractions, right? So that means 10 of these tenths should make one unit. Okay, so 10 of these make the next column. 10 of these make the next column. And then 10 of these make the next column. True? So how is it that 1 over 10, if I have 10 of them, 10 groups of them, isn't that just the same as saying times 10? Now, if you times 10, let's go back to our fractions exercise 3b. I'm doing a bit of a revision here. How do you multiply 1/10 times 10 again? What does that equal to? Hands up if you know or remember. How do you do this again? Let's go with Aegis. You can't. Very good. I'm just testing you. All right, so we got 1/10 times 10 over 1. Aegis is saying making the denominators the same, which we don't need to for times. We only need it for add, subtract, which we'll talk about that later on again. How do we do it again? What's the basic rule of multiplying? In order to multiply fractions, you must do not top to the bottom. Top and top and bottom with bottom. So it should just be top with top, bottom with bottom. But there was a key skill that I was trying to teach you in exercise 3b. Why don't we always just do one top with top, bottom with bottom? Because sometimes the fractions get too big. So we want to make it smaller. Can I make it smaller at the moment?
No.
There is something I can see.
You can divide the 10 by...
Okay. This is called cross-simplifying. And in primary school, and this is what I was trying to illustrate. Remember how I said pick one top, pick one bottom? And you were trying to find a common factor. Now, you're correct. 1 and 10 don't have anything in common. That's why you said no. 10 and 1 have nothing in common. That's why you said no. But 10 and 10 do. There has to be a top number and a bottom number. I haven't told you the reason why, because in that session, I just wanted you to be able to do the skill. Yeah? But in this session, I'm going to show you why. Why is it that I can say 10 fits in a 10, 10 fits in a 10 here, and we cross-simplify, it becomes 1 and 1. The reason being is 1 over 10 times 10 over 1. Let's think about it. You said top and top, bottom and bottom. True? 1 times 10 is on the top. On the bottom, it's 10 times 1. True? Now, if I asked you, is there a difference between 1 times 10 and 10 times 1? No. This is one of the special things about adding and multiplying. Adding and multiplying doesn't actually matter about the order. You can do 2 times 3 or 3 times 2. The answer is still the same. Why is this special? That small switch between 1 and 10 and 10 and 1. Why is that special? Because if I can swap the order and the answer doesn't change, you see what happens here? I'll still keep the 10 and the 1 here. Now let's separate that fraction again. And you see how it ends up being 10 over 10 times 1 over 1. So at the start you told me, nothing similar, can't simplify. Nothing similar, can't simplify. But you see, once I swap the 10 and 1, the positioning, 10 and 10, yes they do. Yes you can. That's why cross-simplifying worked. It only worked because timesing, you can swap the order. 10 doesn't have to be here, 10 can be over there. And if 10 is over here, 10 over 10 can be simplified. But in primary school, instead of teaching that to you, you can imagine that's very confusing. Like, when do you swap them? How do I know to swap? So what teachers normally do is they just say, look at cross-simplifying. If the top number and bottom number has a common factor, cross them off. And that's how they usually teach. And it takes away the concept that the reason why you can do the cross-simplifying is because 1 times 10 is exactly the same as 10 times 1. Why do we swap the order? Because then you can actually simplify top and bottom. Okay? So that's one of the key skills in exercise 3B. If you've forgotten that, watch my video again. That's week 1. That was one of the key skills I wanted you to take away. Not top times top, bottom times bottom. The key skill was simplifying. Do you know how to simplify to make big fractions smaller? Okay? Now, what would the answer end up being? 10 over 10 is the same thing as? 1 whole. And 1 times 1 is 1, which is what we were saying just now. I said 10 of these tenths make 1 unit. Okay, so what I want you to write as part of your notes here, can you please write, when you say 7, it's not just 7 hundredths, it's actually, write this bit down, 7 over 100. This is going to be useful for later on when I teach you why multiplying and dividing why it works the way it does. I need you to understand that when you write 1 here, it's 1/10. When you write 7 here, it means 7 out of 100. When you write 3 here, that actually means 3 wholes, 3 out of 1. When you write 2 here, that's 20 of those ones. Okay, or you can think of it as 2 of those tenths, or 20 of those tenths. Okay? And I'm just going to stop there for you to understand. Okay? All right. Now, today's exercise, we're just doing decimals, but I wanted you to know why we're putting in the place values and why it mattered. Here, let's add. We got them in the columns, so hundredths, tenths, units, tens. In the hundredths column, I've got 7, but this one I have nothing. So what do we fill it with? 0. Very good. Put a 0 in. Adding decimals is exactly the same as how we normally add. So all the columns add with their current units. So sevenths, add 0. 7 hundredths, add 0 hundredths, gives you 7. 0 plus 9, what does that give me? 9. Very good. Don't forget the decimal point. Then 3 plus 9? 12. Remember, because that's 12 units, it's the same thing as saying 2 units and 1/10, because every 10 units is 1/10. That's why we put the 1 over here. So 1/10 plus another 2 tens gives you a total of 3 tenths, which is 30. Okay, and that's how we add them together. Now we got 32.97, and the little gap over here I gave you to fill in, that should then be 32.97. 32.97, now take away 2.86. I put them again in their columns. Hundredths, tenths, units, and you got your tens over here. Let's do it. 7 take away 6. What do I get? Let's go with Joachim. 1, so we get 1 over here. 9 take away 8, Quinn. 1 again, we'll put it in the decimal point. 2 take away 2, let's go with Lewis. 0, and then finally 3 take away nothing gives us 3, very good. So the answer is 30.11. This is the first part of exercise 3E. Okay, so part of exercise 3E, there's a bunch of questions there. I don't need you to do a lot of them, but I need you to show me the steps. Okay, I want to see the question, the method, then the answer. Okay, so that's a small bit of it. Today's main goal is actually to practice multiplying and dividing. Now, before we do that, there is a quick technique, which I won't explain why it works now. I'll explain it next session. But this is what you're going to write down as part of your notes. but some of you might remember it too. When you're multiplying and dividing multiples of 10, because our decimal system is in a metric system, which basically means it's groups of tens. So 10s of these make one of those, and 10 of these make another 10 of one of those. Because they follow the tens, multiplying or dividing tens is really useful. Does anyone remember when you multiply anything to do with tens or multiples of 10, you move the decimal point to the right. Very good. Write this in if you didn't know. It moves to the right. But then if you go backwards, if you divide by multiples of 10, then you move the decimal point to the left. Very good. Here's an example. If I gave you 21.8 times 100, that's multiples of 10. Now, because it's multiples of 10, how many zeros do you see there? 2. But because it's 2, that means you're going to be moving the decimal point, how many points? 2 units to the right. So here we can see 1 unit to the right, so 21.8. You're timesing 100, there are 2 zeros. Moving 2 units to the right. Now that's 1 unit, 2 units. So here's my decimal point. That's going to end up here now. Fill in the gap with a 0. And what does that give me? That gives me 2180 and then a dot. What number is this? 2,180. So when we say, what's 21.8 times 100? The answer is 2,180. Okay, so that's a quick way to multiply by groups of 10. Let's test you. I want to call out about 5 different students, and I'm going to come up with a problem here. Let's go with a second one. Let's make up another one. What if I gave you 5.62 times 10? Can I please have... Okay, let's go. Lennox, what does that give you?
Move the decimal point 1 to the right. So it'd be 56.2.
Beautiful. 56.2 is correct. Let's do another one. I'm going to pick 5 students in total. Let's pick another one. Let's go with Vivian. No, this is just me testing. You just need to write that bit. Yeah? Vivian, if I gave you 14.11 times 1,000, what would this equal to?
14,100.
Beautiful. Now, it's really good that you were doing it all in your head as well. Okay, so yes, how many zeros do we see? There are 3 zeros. How many units do you move to the right? 3. Very good. So we move to the right by 3. 1, 2, 3. So here's the decimal point. So the filling in point is there. And that's why Vivian was doing all this in her head. And she could see 14110, which is actually 14,110. Okay, let's pick another 2 students. Here we go. Let's go, Fraser. Let's try, what if I did a decimal version now? Let's do 0.012 times 1,000.
So it would be 12.
It'd be 12. Very good. Moving again. 3 zeros, 3 place values. So 1, 2, 3. Here's the decimal point. So the numbers I currently see is just the 1, 2, and a point. 12 is correct. Last person. Here we go. Let's pick someone over here. Let's go with Eve. Try. What if I gave you 1.01 times 100? 101 is correct. Beautiful. 101. 2 units to the right because 2 zeros there. Here's the decimal point. It's 101. Was that easy? Hands up if you understood that. All right, beautiful. So I need to get a sense. So that's the multiplying. Dividing is the same, just backwards. Yeah, so moving to the left. Let's try this one. What if I gave you now 15.9 divided by 1,000? Now instead of moving to the right, you're moving to the left. Now, how many units? 3, because there are 3 zeros. So here we go. 1 to the left, 2 to the left, 3 to the left. There's my new decimal point. Any gap, fill with a 0. So in this case, what is my answer? It should be, again, 0.0159. That's my answer. Okay, so point. So where that decimal point is, that's there. 10, 11, 15, 19. So when I ask, what is 15.9 divided by 1,000? That's my answer. Okay, I'm going to pick another 2 students to try. So here we go. What if I made up a number? Let's go with 4012.9 divided by 100. Who wants to have a go? Oh, Fraser again. Let's go.
So it would be 49 forward 2.
Yeah.
So it would be 40.139.
Beautiful. So here's 2 decimals back with 2 zeros. And that gives you 40. Put the dot in. 129. 40.129 is correct. Sam, let's try. What if I gave you 0.100003 divided by 100?
So you put the decimal point to the left 2 times.
Ooh, yes. 1, 2.
1, 2, and then you have to fill in the places where there's nothing with the 0.
Yep.
And that's your answer.
All right, let's read it out. So you got point.
100.11.
Beautiful. I did those many zeros because when students see that, they often move to the right intuitively because they're like, no way, we're going back to the left. And they naturally go to the right, and that's when they're wrong. You only go to the right if it's times. Because it's divide, you're moving to the left by 2. Okay, and so wherever you put the decimal point, just count, just read it out. So it'll be 0, 0, 1, 4 zeros, and then 1, 3. Hands up if you totally understood that. All right, beautiful. That was the key skill because you need that understanding to do this bit. Flip over the pages. This is one of our key skills. So today, my goal is to teach you how to multiply decimals and then how to divide decimals. But in order to do that, you had to learn that movement just now. Okay, so here we go. If I asked you to do 3.29 times 1.4, we don't know. Okay, well, we kind of do know, but it's a pain in the butt. Because you only learned 12 times tables, yeah? So 1, 2, 3, all the way up to 12. We never learned 3.29 times tables. And we never learned 1.4 times tables either. So this is a problem. We don't know how to multiply that. So what we do instead, we say, let's change it to something that we know. See that 3.29? That's not something I know. It's not a whole number. So what I'm going to do is I'm going to convert it to a whole number. So how do I do that? Decimal point is right here. That makes 3 a 1. But if I can move the decimal point over here, that makes it a whole number. It becomes 329. Now, how do I move the decimal point 2 places to the right? Do I multiply or divide? You multiply. Multiply moves to the right. But what do I multiply by? 100, because 100 has 2 zeros. That's why you move 2 places forward. So I'm going to multiply this by 100. And what does that make it? It now makes it, instead of 3.29, you get 329. Then you do the same thing for the next one. See, I don't know 1.4 times tables, but I know it if it's whole numbers. So how do I make this a whole number is if the decimal point was over here. But that means one jump. Times by 10, very good. So we picked up that we need to times, in this case, by one place value, which is 10. So, because I changed the numbers now, this is now going to be 329 times 14. I want you to rewrite this again. Here we go. Let's rewrite this again. Thanks, your rates. No. Your rates, sit down. Thank you, sit down. Thank you. Thank you. Your rates. Thank you. Wait. No. My rules are still the same. We know our 3 rules. When I'm speaking, you're listening. When someone else is speaking, you're listening. And all of those 2 is out of respect. What you just did just there, yes, there are disruptions out there, but that's what they're doing. They want disruptions, or they're doing an experiment. That's their class. In my class, I have the 3 rules because it's one, respect while I'm teaching. You're listening or you're actively writing notes. And when you do something opposite to that, that's disrespect. The work that I put in, the amount of time I put in to write the notes, and the lesson plans that I make for you, you're essentially giving me a backslap across the face and saying, I'm not interested. Okay, and so that's why I find that as a disrespectful behavior or action that you're doing towards me. I prefer that when those kind of things happen, I prefer you think about me and what I've done for you. Okay? All right, team, let's continue. Sorry, that was recorded as well, so if you watch this bit, just skip it. Here we go. So we've changed the problem. Instead of 3.29 times 1.4, I want you now to rewrite it as 329 times 14.
Will we do that in our books?
Yes.
We have to write times 119 14.
Yeah. Very good. So once we've got 329 times 14, this is more familiar to what we did in year 7 and primary school with multiplying long multiplication. Let's remind ourselves how to multiply long multiplication again. What's the first step in this process? Can I please have, let's go with Shakira. Oh yeah, you are here today. Yep. Shakira, what's the first step? How do I multiply 329 by 14? What's the first step? What are you going to do? 4 times 9. So we take the units. Okay, we break the 14 into its columns. So we look at the 4s. Those are units. So ones, 4 groups of 9 gives me 36. So 36 has 6 units, but 3 tens. That's why we carry the 3 over here, because that's the tens column. Yeah? Then 4 units again, 4 groups of 2. Now remember, this is not just 2, this is actually 20. So 4 times 20 is actually 80. That's why it belongs in this group here. But 4 times 2, which is 8, with an extra 3 tens, 11 tens. Now 11 tens is equivalent to 110. Yeah, 11 tens is equal to 110 units. And that's why 110 units we keep. See, 110, we keep the tens. That's why we write a 1 here and we carry the 1 over here. See that? So that's what 11 means. 11 isn't just 11. 11 is 11 tens. So the 1 goes here and the hundreds go over there. Now we do the same thing. We say how many 4 groups of 3? Remember, it's not just 3, it's 3 hundreds. 4 times 3, which is 12. So that's 12 of these hundreds plus another one of these hundreds gives you 13 hundreds. And if you think about 1300, that's what 1300 means. That's 1300. That's why the 13 comes over here. That's why you have the 20 empties spots here. Yeah? So it's the language of what the columns actually represent. All right. We've done the 4s. The next step. Some students miss on this step here. What do you do in the next step?
0.
Yes. Why do we add the 0? Harrison.
Multiplying by tens.
Very good, because this column now represents tens, not units. So you're starting in the tens. So you're saying, if I've got one group of tens here, and I'm going one group of these 9s, it's not 1 times 9, it's actually 10 times 9. So 1 times the 9, what does that give me? 9. So remember, that's not 9 units, it's 90. That's why the 9's here. Okay? Then we do the same again. 1 times 2, what does that give you? 2. Very good. So we carry on. So 10. And remember, that's not just 2. That's actually 10 times 20. That's why it ends over here. That's why it's 200. And then finally, 1 times a 3. 3. Again, that's 10 times 3. That's 300. So 10 times 300 is 3,000. That's why it's in this column. We add them together. You get 6. 1 plus 9 is 10. Carry the 1. 1 plus 3 is 4. 4 plus 2 is 6. And then 1 plus 3 is 4. I'm done. Why am I not? What's wrong with my answer? I did everything. Oh, decimal point. So where do I put the decimal point? Do we guess? Do I just put it in the middle? Do I put it over here? Do I put it over here or is it over here? So there's 1, 2, 3, 4. Which position should the decimal point go to? Let's go with Sam. He's thinking 3. So we got 1 for 3. Hands up for 3s. Hands up for position 3. So we got 1, 2, 3, 4, 5, 6, 7. 7 students for 3. Hands up for position 4. 0 for position 4. Hands up for position 2. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a double up here. 9. Hands up for position 1, which is over here. All right. Now, if you weren't sure, so there's 0 here. I don't want you to guess. there's a logic to this. Remember, the only reason why we can do 329 times 14 is because I changed the numbers. But that means it wasn't real. The number wasn't real. I just made it easier for myself. How did I make it easier? Remember the start? We times by 10, and then we times by 100. Because I inflated it, thanks T, if I inflated it by that much, then to bring it back to the original amount, I have to shrink it. If I times by 10, what's the opposite of timesing 10? Dividing. So this one should have been divide 10. This one, instead of timesing 100, divided by 100. Now, you guys have already learnt how to move the decimal points. Our original answer was 4,606, but I got to divide it by 100, then I got to divide it by 10 to go backwards. So how many zeros do I move backwards? 3. Because that was my whole number. I times it by 100 before, so you got to go back twice. I times by 10, so I got to go back once. So if you count it, it's 1, 2, 3. The answer is 4.606, which makes more sense because if you think about it, 3.29 times 1, how is it going to be 46? Doesn't make sense. Position 3 seems a bit too large. 3 times 1 is closer to 4. So, in fact, the answer should be closer to 4 point something. Get me? So there's a bit of logic there. Yeah? So, how did I do it? That's the reasoning. If you change the numbers, you have to change it back. We changed it to make the process easier, and then we got to switch it back to know what the actual answer is. Yes, Osman?
I think also if you count the numbers like after this.
Yes, so this is what your teachers would have taught you. They didn't teach it the way I just explained it. This is what your primary school teachers, maybe year 7, would have taught you. They would have taught you this way. They said count this. So if you moved it twice, two place values, so that's 2. And then this is 1 place value, add them together. 2 plus 1, that means it's 3 backwards. Most students will remember that if they practice it, but if they don't practice it, they forget. That's why I teach it this way. I teach it this way because there's a logic to why you were doing something, and then how do you go backwards from that? Okay, so the reasoning is here, but if you prefer this to easily remember, that's how they normally teach in primary school. Okay, so they normally tell you to count the decimals and then add it at the end. If you understand what I just taught you, that times 100 times 10, it'll make sense why division you don't have to do it. I'll show you in the division bit so you can see the difference. Okay? All right, team, so the answer, write in your notes there, the answer is 4.606. I do want you to note these 2 little details here. Times 100, divide 100. Times 10, divide 10, because it's the reasoning why it works. Make sure to have that down. And then we'll do one last example in division, and I'll show you why is it that multiplication you move the decimals, and then when it comes to division, you don't move the decimals. You'll see why in the fraction form. Here we go. Last example for today. 0.5045. You're trying to divide this by 0.8. Nice and ears towards the board. One last example. What's the problem with division? We don't know how to divide by 0.8. 0.8 is too hard. It's a decimal. We didn't learn decimals. We learnt multiples of whole numbers. So this 0.8 is a problem. Because it's a problem, we're going to convert it. Now, how do I convert 0.8 to a whole number? What would you have to do? Times by 10, because you want 1 decimal forward. Times that by 10. Now, what I want you to see is, why does this happen with division where you don't have to actually change the decimals? Watch what happens here. See, 0.5045 is this number. Divide is this symbol. 0.8 is the denominator. Now, if I write it as a fraction, what they just told me, that if I times 10 to 0.8, it should give me 8 on the bottom. But remember with fractions, whatever you do to the bottom, you must, you have to do to the top. And the reason why is you got to keep the fraction the same. It's like a half, 2/4, 3/6. If you don't times the top, it's not going to be the same fraction anymore. So this fraction, if you times the bottom by 10, you have to times the top by 10. That changes this now to 5.045. This fraction is actually the same as this fraction. That means if I asked you to work out, oh yeah, I must have done this wrong. The decimal point should be over here. Fix that decimal point, it should be over here, 5.045. 0.045, cross this decimal off. I'm asking how many 8s fit into 5.045. This one we can do. This one we can do because we can divide by 8s. But you can see whatever this answer is going to be, that answer is equivalent to this answer. So unlike multiplication, the ending result, you don't have to change the decimals in any way. You don't have to move backwards. You don't have to move forwards. Is because this is already equal to this. There's nothing different about it. This one is actually equal to that. It's like saying half equals to 2/4, and that's the same thing as 0.5. You don't have to do anything to it. You don't have to change this decimal answer. Unlike multiplication, you did. Division, you didn't. You have to. Oh, sorry. Multiplication, you have to. Division, you don't have to. Okay? All right, here we go. Let's do short division to see if you remember how to do division again. How many 8s in 5? 0, because 5 is too small. 8's a lot bigger. Good. So because the 5 couldn't fit, we carry the 5 units into the tens column. That becomes 50. Yeah, because remember, these are always 10 more than the previous place value. So 50. Now you ask yourself, let's put the decimal in. So that's a decimal. How many 8s fit into 50? Good, because 8 times 6 is 48. And to get to 50, I've got a remainder of 2. What do I do with that 2? Yes, carry it over to the next column. So now it becomes not 2 plus 4, but it becomes 24. So good. How many 3s in 24? Lennox just put up his fingers as 3. Very good. Remainder 0. So I carry the 0 over. And then how many 8s into 5? 0 again. And then you can continue this process by adding on a 0, carry on the 5. And then how many 8s in 50 again? 6. Remainder 2. What's the pattern? It feels like there's a pattern, but it's not. Remember, you've got to carry on a 0. How many 3s into now 20? 2. Remainder 4. And then finally put on this last 0. That's a 40 now. How many 8s in 40? 5. So the decimal answer should be 0.630625. When I say, what is 0.5045 divided by 0.8? I've changed the problem to 5.045 divided by 8. And it's a lot easier. Okay, now that skill, I don't expect all of you to learn. Because there's still bits and pieces, division, multiplication skills, there's still errors there. Your key learning bit is the top bit. If you can understand that first bit, this bit here, that's the main bit that I'm really looking at. Okay, so that's exercise 3E, that's your fluency section. Cool? Remember tomorrow, if you're feeling a bit tight in today's session, it's okay, because remember tomorrow you've got a half session, and that's fully your time. Okay, that's your time to work on 3E, and you also got whatever's left over today. Cool? All right, team, I want to stop there. Thank you for listening. That was really good for our second lesson of this term. Welcome back.